Hello everybody, today we're doing BJU Press Pre-Algebra's section 4.2. It's titled Greatest Common Factor, and we're on page 175 in the book. Number 1 says, numbers or expressions whose greatest common factor is 1 are said to be, this was a definition, the answer is relatively prime. Next one is, so we're doing 1 to 13 odd. Number 3, so we're going to use a combined factor ladder to factor the GCF of each pair of numbers. Number 3 is 12 and 40. All right, so let's set up our factor ladder. We've got 12, we've got 40. We're doing a combined factor ladder. And we're going to start by trying to find the smallest prime number that's going to divide out of both 12 and 40. That would be 2. So then we do 12 divided by 2. That leaves us with 6. And 40 divided by 2. That leaves us with 20. Let's look at it again. What is the smallest prime number that divides out of both 6 and 20? It's going to be 2 again. So that leaves us with 3 and leaves us with 10. And we're done with that. There's no more prime numbers that will divide out of both of them, which means our GCF is the numbers that we did the dividing, that we divided out of both. You could write 2 squared or 2 times 2. Either way, the GCF is 4. Number 5. 40 and 50. Let's write our factor ladder is going to be 40, 50. Set it up like this. And we're going to start again with the smallest prime number that divides out of both 40 and 50. They're both even, so this is going to be 2. 40 divided by 2 is 20. 50 divided by 2 is 25. Okay, we can't do 2 any longer because 25 is not even. We can't do 3. That would be the next prime number. 4 is not prime. 5. 5 does divide out of both of these. So 20 divided by 5 leaves me with 4, and 25 divided by 5 leaves me with 5. And there is no prime number that divides out of both 4 and 5. So we're done with our ladder. Our GCF is the numbers that we have. We multiply them. That gets us 10. Number 7, 36 and 48. Okay, so we've got a 36, 48. Set up our ladder. Smallest prime number that divides out of both would be 2. That leaves us with 18 and 24. And 2 will work again. That leaves us with 9 and 12. All right, we can't do 2. Let's check 3. Yes, we can divide both of these by 3. That leaves us with 3 and 4. And we're done with that. There's no more prime numbers that divide out of both 3 and 4. So our GCF is 2 squared times 3, which is 12. Number 9, use prime factorizations to find the GCF of each pair of numbers. Okay, so number 9, we're comparing 35 and 75. And we need to do the prime factorization of each one of these. I don't care how you figure out the prime factorization for 35 and 75. You probably will need some extra side work if you can't do it right off the top of your head. You can either do a factor ladder or you can do a factor tree. I will be doing primarily factor ladders. In fact, I might come over here and just show you real quick for this one. So if I'm going to do 35 to find the prime factorization, I'm going to be doing, I'm going to be doing my side work over here real quick to find that 35 has a prime factorization of 5 times 7. And then I might hop over here and do it for 75. Let's see. And I like to take my ladders all the way down to 1, so then I'm going to find that 75 has a prime factorization of 3 times 5 times 5. Okay, so that's the prime factorization that they're referring to. So you should be doing that first. And then in order to find the GCF, you're going to do the things that are matched up as a pair, which in this case is just a pair of 5s. So our GCF is 5. All right, so now for number 11, we're checking 21 and 58. So I'm going to write the prime factorizations here. I'm not going to do the side work like I did on number 9 with 35 and 75. I'm assuming that you can do that on your own and find the prime factorizations by either doing the factor ladder or the factor tree. I'm just going to go straight into writing it down. So 21, the prime factorization is 3 times 7. And 58, the prime factorization is 2 times 29. These do not have any like prime factors. That means you've got to just go with 1. So in this case, the GCF is just 1. It's the only common factor that they have. Number 13, 40 and 60. Okay, so I'm going to write down the prime factorization for 40 and the prime factorization for 60. If you can't do that off the top of your head, you're going to be making ladders over here, right? I'm not going to go through the whole process. Then you would do 60. Not going to go through the whole process. I'm just going to write it down. 2 times 2 times 2 times 5. 60 is 2 times 2 times 3 times 5. So to find the GCF, you're checking out the ones that are common, the common factors. We've got 2 2s and a 5. So 2 squared times 5 is 4 times 5, or 20 is the GCF. What's next here? My list. Number 14, explain the process of finding the GCF. So the first thing you do is write the prime factorization. So finding the GCF, the first thing you need is write the prime factorization. Right, and you can find the prime factorization by either doing the ladders or the trees. Again, try to get yourself used to doing the ladders. So you're going to write the prime factorization, and then we find the common factors. And then find the common factors. So, okay. All right, next section is 15 to 41 odd. Number 15, state whether each pair of numbers is relatively prime RP or not relatively prime NRP. So if you remember, relatively prime is when they only have the same factor of 1. We actually just found out in number 11 when we found out that for 21 and 58, the GCF was only 1. We actually just found out that 21 and 58 are relatively prime. A little side note there. But anyway, so back over to number 15. So we're checking for 21 and 25. Now, you're not just going to be like staring at this and be like, I really don't know. So instead, what you would do is for 21 and 25, if you don't know the answer right away, don't just like guess and stare at it. It means just go ahead and do some side work and then find out what's the prime factorization of 21, what's the prime factorization of 25, and then you're going to see, oh wait, 21 is 3 and 7, 25 is 2 5s. There's nothing that matches up, which means the only thing that's the same is the 1. And in that case, they are relatively prime. Number 17, we have 49 and 105. And these are not relatively prime because they both have a factor of 7. So you would do some side work over here, like we did on these guys. You would do some side work for 49 and 105 and do all the work to figure it out before you answer the question. Number 19, find the GCF of the given numbers. So 42 and 70. Okay, so 42 is going to be, I can take out a 2. That leaves me with 21, which is a 3 and a 7. So 2 times 3 times 7. Number 7, for 70, I can take out a 2, which leaves me with 35, which is 3 times 5. Okay, so that's what you would do if you're doing it in your head. Again, don't stare at it. Don't not know how to do it. Just do the side work if you don't know. Okay, and then you could do it for 70 as well. This is the side work. I'm not going to go through this for all of these problems. I'm just going to be writing down what the prime factorization is, and I'm trusting that you all are going to be doing all of that work to find the prime factorization. All right, so back to the actual problem. The GCF then is whatever matches up. So 2 times 3. So number 19. Wait, did I do something wrong? Yeah, I must have done something wrong back here. Oh, 235, 5 times 7, wait, 70 is 2 times 5 times 7. Darn it, and I wrote 2 times 3 times 7. Okay, so right here, let me erase this. That's not the eraser. This right here. Oops, why does it go back to that? Oh my word, it just automatically changes things on me. I have no idea what's happening. Okay, back to my pencil, I think. Okay, so 70 is 2 times 5 times 7. All right, so that means we have 2s and we have 7s that match up. And I'll fix my error here. 2 times 7. Okay, so number 19, the answer is 14. Sorry about that. Number 21. 90 and 104. Okay, prime factorization for 90 is 2 times 3 times 3 times 5. Prime factorization for 104 is 2 times 2 times 2 times 13. You probably couldn't do that one in your head, so I would expect there are some side work factor ladders going on there. So GCF is going to be the ones that match up. So 2, well, that's it. Number 21, the answer is 2. 23. We've got 10, 25, and 40. All right, so this is a triple one. I'll show you a factor ladder for this because we did do this in class together as well. So let's do a triple factor ladder. All right, smallest prime number is 2, not going to work. 3, not going to work. 5 divides out of all of them. So 10 divided by 5 is 2, 25 divided by 5 is 5, and 40 divided by 5 is 8. And that's all. That's all the prime factors that come out of all of them. So the GCF of all 3 is 5. Number 25. 8, 12, and 28. Okay, so I'll do it again for a factor ladder here. You could do them individually. You could do them double, how we were doing them. Smallest prime number that divides out of all 3 is 2. 8 divided by 2 is 4. 12 divided by 2 is 6. 28 divided by 2 is 14. We can do another 2. So 4 divided by 2 is 2. 6 divided by 2 is 3. 14 divided by 2 is 7. So that means we've got GCF is 4. Number 27. 28, 42, and 56. All right, I'll do a ladder here. You could just do the prime factorizations like I did earlier. You know, it doesn't specify what method to use to get the prime factorization or to get the GCF. So I'm going to go with this method. Let's divide both or all three by 2. That leaves me with 14, 21, and 28. I think we're done at, let me see. Let me just double check here. Oh, they all divide by 7. I see that now. Okay, so 14 divided by 7 is 2, 21 divided by 7 is 3, 28 divided by 7 is 4. So that means my GCF is 2 times 7, or 14. 29, so now we're doing the expressions. So of course in algebra we need to include some letters. Why not? That's what makes it algebra. So 9c cubed d to the 5th and 12c to the 4th d to the 4th. So let's write the prime factorization for the 9c cubed d to the 5th. That would look like 9, which is 3 times 3. Then we have 3 c's and we have 5 d's. And then we have 12 c to the 4th d to the 4th. 12 is 2 times 2 times 3, and then 4 c's and 4 d's. So the GCF is going to be a set of 3's, and then 1, 2, 3 c's, or c cubed, and then we've got 1, 2, 3, 4 d's. Okay, so number 29, 3c cubed d to the 4th. Number 31, m to the 18th n squared and m to the 15th p to the 6th. Okay. Wow, so this would be really ridiculous to write out 18 m's or 15 m's. But what I can tell is if I were to write out 18 m's, I would know that 15 of them are going to be paired up, right? Because here's 18, here's 15. So the GCF, I'm not even going to bother writing it out. I'm just going to talk through it with you. I can match up 15 of those. When I get to the others, there's no n's, like in both. So this one has n, but there's no n's over here. Also, this guy has p's. There's no p's right here. So all I have for my GCF are the 15 m's, m to the 15th, that are the same. Number 33. So we have 16 x to the 5th y squared z to the 4th. We have 64 x cubed yz. And then we have 36 x to the 5th y to the 7th. Okay, so let's see. So 16 x to the 5th y squared z to the 4th is going to be 2 times 2 times 2 times 2. And then 1, 2, 3, 4, 5. Y, and z, 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 z. Now maybe you don't want to. Since the number 31, since we kind of like talked through how that m to the 15th and the m to the 18th worked, maybe you don't want to write out all of these variables anymore. I'm going to do it for this time. But maybe you can think through it and be like, oh, well, there actually is a shortcut. And that would be fine too. So for 64, I think that's 2 to the 6th. Is it not? So 1, 2, 3, 4, 5, 6. And then we have X, 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 Y, Z. And then for 36, wait, X to the 5th, Y to the 7th equals 36 is going to be 2 times 18, which is 3 times, okay, no, wait. I should do 2 times 18, which is 2 times 9, which is 3 times 3. And then we have X, 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 and 7 Ys. Okay, so maybe after all of this one, you'll be able to see it's pretty valuable to do the prime factorization of the number part. That's all we have for that. So 33 is going to be 4. So GCF is going to be 4. But then maybe you can start noticing the pattern going on here with the variables. So 1, 2, 3 x's are going to match up. And then if you look at these x's, x to the 5th, x cubed, x to the 5th, you're actually just going to end up taking the one that's the smaller of the 3, which comparing x to the 5th, x cubed, and x to the 5th is x cubed. So notice that that ends up what's in our answer. Moving on to the y's. So we've got a y matching up in all of them, but only one y is matching up in all of them. So I'm just going to have one y, and then if I look at the y's up in my original, I have y squared, y to the 7th. The smallest amount is the 1y. So that's what we have that's common. We have one common y in all of them. So that ends up being our GCF. So there is a little bit of a shortcut to doing these as you get better at them and as you understand what's actually happening in the problem. Number 35, state whether the expressions are relatively prime or not relatively prime. In number 35, these would be relatively prime because the 12 and the 25, and then also those variables thrown in there, there's nothing that's matching up. Number 37, we have 21ab and 51c squared. Let me see. So we can take out a 3 out of both of them because 21, those digits add to 3, and 51, those digits add to 6, which is divisible by 3. So this is not relatively prime because you can take out a 3. Let's move on to number 39. Find the GCF of the given prime factorization. Well, that was nice. They already did it for us. So 2 times 3 times 3 times 11 and 3 times 5 times 11 times 11. So I just kind of expanded it, what they wrote down, and I put them on top of each other so that I can find my things that match up, which are 3 and 11. So my GCF here is going to end up being 33. Number 41. Let's do that. So we've got 3 times 5. We've got 2 times 2 times 5. And then we've got 2 times 2 times 2 times 3. Okay, I copied all those down right. Wow. Well, it looks to me like these guys must be relatively prime, all 3 of them, because there's one number, here's the second number, here's the third number. I can see things matching up between these two, and I can see the 3s matching up between the first one and the second one. I can see the 5s matching up between and so on, but I don't have any factors that's the same on all 3 of them. So that means my GCF is going to be 1. Okay, so let's see. We did up to 41 odd. What do we have next? 47 to 55 odd. Find the consecutive integers that each root lies between. Number 47, The square root of 299 lies between 17 and 18. Number 49. Estimate the sum or difference by rounding each number to the nearest hundred. So we have negative 4,578 plus 321. We're going to round each number to the nearest hundred. So for this one, it's going to be negative 4,600 plus, and for this one, that's in the hundred spot, that's going to stay 300. Then we have the signs are different, so we find the difference, which is 4,300. We're going to keep it negative because the larger number was negative. Number 51. Translate each sentence into an equation with n as the variable. The product of negative 28 and a number, so the product tells me I'm multiplying. The product of what two things am I multiplying? I'm multiplying negative 28 and a number is 252. Is our verb. That's where we're going to put our equal sign. And 252. Number 53. The quotient of a number and 19 is 456. So the quotient of what two things? That means I'm going to divide those two things, the number and 19. Is my equal sign, 456. Number 55, solve 12 minus s over 5 is less than 20. Okay, so here's our inequality. Where's our variable? Right here. What is being done to our variable? Well, the first thing we would do is divide it by 5. Negative 5, actually. Let's just go ahead and go like this. Plus the opposite and throw that negative down on the bottom with the number. So the first thing we would do is divide it by negative 5. The second thing we would do is add 12 to it, which means we're going to do the last thing first. We're going to undo the last thing first and subtract 12. If you do it on the left, you do it on the right. That leaves me with s divided by negative 5 is less than 8. Now I need to multiply both sides by negative 5. That's going to give me s. I multiplied an inequality, both sides of an inequality, by a negative. That means I need to flip my sign and then get negative 40. So the answer is A. And lastly, number 56. How many bushels of grain must a farmer sell if the selling price is $3 per bushel and the farmer wants to get at least $2,400? Okay, very first thing we're going to do is say, what is the variable? We need to define it based off of what the question is. How many bushels? So B equals bushels. We've defined our variable. Always the first step. The selling price is $3 per bushel, so 3B. And the farmer wants to get at least $2,400. So he's cool with it being $2,400, but he'd also be cool with it if it's greater than $24 because he wants at least, $2,400. So here's our inequality. We'll divide both sides by 3, find out that B, the number of bushels, has to be greater than 800. A says no more than 800. That's not true. B says less than 800. That's not true. C says only 800, which would have to be equal. D is not enough information. Well, I don't agree with that because I found an answer. E would be our solution because none of them say greater than or equal to 800. All right, we are done. Check section 4.2. Thank you, guys.